Are you familiar with the Cybertruck? You have, of course, as everyone is aware. However, this car is altering the game in a revolutionary way, and no one seems to be talking about it. There are absolutely amazing synergies and cost savings coming from SpaceX and Tesla's cooperation that no other manufacturer can match. Welcome to this video, Mesa, where we'll explore the universe of Tesla's achievements and its never-ending search for novel concepts using first principles analysis. Charles Kuhlman, a talented alloy specialist who had previously worked at Apple and SpaceX, was acquired by Tesla in 2015. Kuhlman, who holds a PhD in material science and engineering, brought a plethora of expertise to the table. His knowledge has been incorporated into the Cybertruck in ways that will fundamentally alter the automotive sector. Make sure you subscribe to Tesla Stock News before we get started. That being said, let's begin this video. For the time being, let's set aside the 8,000-ton gigapress intended for the Cybertruck's rear body. Sure, it's a significant issue, but that's not what we're discussing today. We are discussing the one feature of the Cybertruck that has an indirect bearing on SpaceX's Starship. It's an example of how revolutionary Tesla really is. The fundamental ideas that drive Tesla's success are its continuous improvement and adoption of novel concepts. It's like breathing the company's own air. An expert on alloys, Charles Kuhlman joined Tesla and SpaceX in 2015 after leaving Apple. At both companies, he serves as the head of materials engineering. Kuhlman co-founded Questec, a business that created and marketed a number of novel materials engineering instruments, procedures, and alloys after receiving his PhD in materials science and engineering from Northwestern. After that, he headed Apple's product design department for 3 years before joining SpaceX and Tesla. We learned a few months ago that Steel Dynamics and Tesla had inked a supply contract for the Cybertruck. Tesla will receive steel from Steel Dynamics, a new electric arc furnace steel factory that is currently being built in Texas. About 25% of the steel produced worldwide is produced using the EVE process, which melts steel scraps, using high current electric arcs to create liquid steel. According to Metal Center News, Ferris 85's new factory in Sinton, Texas will house and run the biggest slitting line in North America. The slitter's ability to create slit widths between 8 and 85 inches is essential for building the Cybertruck's body. Similar to how it builds its Hardware 3 and Hardware 4 fully autonomous chips internally but outsources manufacturing, Tesla is producing its alloy but will need to devise new ways to use it in production. With the new stainless steel alloy for the Cybertruck, a comparable circumstance occurs. Tucked away in plain sight, the secret to Tesla's hegemony is the SDI factory in Sinton, Texas, 3 hours drive from Giga Texas and Austin. The ultra-hard 30x cold-rolled stainless steel proprietary alloy, which Elon Musk says has the potential to shatter a stamping press, is the key to the puzzle. The distinctive planar design of Cybertruck is due to this special alloy, which cannot be stamped like regular steel. Let's examine the specifics in more detail. In his reply to Viv, Elon Musk makes an intriguing discovery: the new steel alloy was first used in SpaceX's Starship spacecraft before being incorporated into the Cybertruck. Elon notes that although titanium skins were initially intended for the Cybertruck, stainless steel turned out to be a far more robust choice for Tesla, but this choice is more complicated than it first appears. Elon's real goal is to increase demand and lower material costs by raising manufacturing volume of the alloys that SpaceX finally chooses. It's a smart move that benefits Tesla and SpaceX equally, because decreased costs are a result of increased volumes. It is noteworthy that the need for alloys in space applications is not the same as it is on Earth. Space alloys need to be able to endure extremely high temperatures when they re-enter the Earth's atmosphere, but on Earth, rust inhibition is the primary concern. Notwithstanding this disparity, it wouldn't be shocking to see Tesla develop the Cybertruck in the same way that SpaceX does as it continues to investigate other materials. Elon's remarks from the previous summer demonstrate Tesla's dedication to continuously developing materials. As metal compositions and forming techniques vary quickly, Tesla will make less sense out of conventional naming conventions like 304L. Tesla is a company that is built on continuous research and development. In contrast to traditional manufacturers who stick with materials and design for decades, they continuously innovate and apply improvements to the basic level of chemistry for the advantage of the typical consumer. The Cybertruck's incredible resistance to dents, scratches, and rust is only one of its amazing attributes. The situation with rust in particular is more serious than most people realize. What then are the cold rolling alloys 30X and 304L made of? I could spend hours discussing this subject, but for now allow me to give you the main ideas and conclusions. Some sheet metal engineers could take offense when Elon Musk calls stainless steel ultra-hard, since the proper engineering term is strong in terms of strength or yield strength. Although Elon is aware of this, he also recognizes that yield strength may not be a concept that the typical Tesla fan is familiar with. The idea of yield stress or yield strength denotes the critical point at which a material begins to distort plastically. When a substance is subjected to external forces that cause it to permanently change shape, this is referred to as plastic behavior. In essence, yield strength establishes the highest load or force that may be applied without permanently deforming the material or changing its shape. Let's now explore the fascinating history of the 30X and its significance. Thomas Bradford's curious mind was rewarded with an answer towards the end of 2019. He had asked Elon Musk a question, speculating on whether the metal type was indicated by the 30X, where X stood for an unidentified variable like 303 or 304, or he wondered if that actually meant 30 times the hardness. Elon acknowledged that was a fantastic question and answered with admiration. He disclosed that it was a novel variety of stainless steel from the 300 series, which had undergone several cold working procedures. The specific composition at that time was neither precisely 303 or 304, depending on the kilotonnage of pressure applied. Instead, it was an inventive series that repeatedly experimented with cold pressing. The 300 series of stainless steel is a genuine alloy family that is renowned for its affordability, resilience to corrosion, and durability. Elon stated that the intended alloy was to be 3 millimeters thick, or roughly 0.118 inches. The steel of Cybertruck's doors is 3 times thicker than most other door panels, as can be seen from this thickness comparison. Steel has a crystal structure that can be body-centered cubic, face-centered cubic, or cubic. It changes from one phase of crystalline structure to another when heated or then cooled. When talking about terminology like authentic or martensitic, this distinction is essential. The alloys used to make the Cybertruck are composed of austenitic stainless steel, which is not magnetic. It can, however, develop mild magnetic characteristics via cold rolling or cold working. The 300 series includes a range of stainless steel varieties that are classified as austenitic. Moreover, Elon has before tweeted about the meaning of the letter L in a concise manner. That indicates extremely low carbon in this scenario. As an example, 304 stainless. The maximum carbon percentage in steel is 0.08%, while the maximum carbon content in 304L is 0.03%. 304L's lower carbon concentration helps it in corrosive environments and during welding, even if it may be structurally weaker than 304. It is assumed that joints made by welding will endure over time. Considering the various stainless steel series varieties, each has advantages, disadvantages, and trade-offs similar to battery chemistries. Elon's last statement mentioned the S304L type of stainless steel. It's crucial to remember that this will be a custom alloy, thus Tesla and SpaceX won't be using any of the conventional 300 series alloys. We do know that the alloy will go through cold rolling, a work hardening and finishing procedure that compresses hot rolled steel between a number of power rollers to create thinner and harder steel sheets, even though the specifics are yet unknown. Applications requiring exceptional strength, surface quality, and precision are well suited for cold rolled stainless steel. Cold rolling does not require layers, unlike what many people think. Its major goal is to provide consistency during the cold rolling process by keeping tight tolerances in thickness and flatness. The crystalline structure of hot-rolled steel elongates and dislocates in the direction of the roll as pressure is applied to it. This effectively increases the yield strength of the material. Recall that Ferris 85 provided Tesla with hot-rolled steel. After heat rolling, cold rolling produces steel that is more resistant to stress, breaking, and deformation. Let's now address a popular misperception. We don't need to brag about the alloy being 30 times harder or stress how well it can withstand 30 cycles of rolling. Though it's theoretically conceivable to stretch the boundaries, it makes no sense from a manufacturing standpoint. Rolling more doesn't make tolerances instantly get better forever. In actuality, internal stress increases with each roll, and we don't want to jeopardize the material's integrity. Furthermore, when Elon Musk first unveiled this idea, that wasn't even his intention. The real discovery from Elon Musk is that it is difficult to stamp this extremely hard 30X steel. The remarkable Cybertruck prototype was made with a deep score on the inside, which is just what it takes to bend it. This is where the enchantment takes place. Tesla uses a state-of-the-art method that reduces the need for forming operations in the production of the body panels for the Cybertruck, put an end to conventional stamping, and take advantage of laser cutting's accuracy and efficiency. My friends, they are game changers. In Astounding Films, Elon Musk demonstrated the Cybertruck's extraordinary durability. The video skin endured sledgehammer blows at close range and 9mm full metal jacket bullets fired from only 10 meters away. This is a completely new degree of resilience. This is only the start. There are lots of great opportunities on the horizon. If you felt this video was informative, please like it. For additional mind-blowing Tesla stuff, think about subscribing. Don't forget that your next journey is waiting for you. I hope you have an amazing day.